So here we have to show that y2, here y2 represents second derivative of y with respect to x. That's equals to 2 times y times the first derivative of y with respect to x. Let me state this here. So y2 is simply second derivative of y with respect to x, and y1 represents first derivative of y with respect to x. Right. Now we'll just begin by whatever is provided with us. So here we are given that y is equals to tangent of x. Now let's take the derivative of y with respect to x. So that means derivative of tangent of x is going to give us secant squared x, or simply secant of x whole square. So let's call this number 1 and this is number 2. Now derivative of y with respect to x, this is simply y1. Now we'll again take the derivative of equation number 2 with respect to x. So that gives us second derivative of y with respect to x, which is equals to 2 times secant of x raised to the power of 2 minus 1 times derivative with respect to x of secant of x. So here we have used the power rule and the chain rule. So that means this gives us 2 times secant of x, and derivative of the secant function is secant of x times tangent of x. So this gives us y2 equals to 2 times secant squared x times tangent of x. Now we have found out the first derivative and the second derivative as well. Now we have to show that y2 equals to 2y times y1. So let's do that. So here we have to show y2 is equals to 2y times y1. Well, we already have the value of y. So here y is tangent of x and y1 is secant x squared. So that's fine. We have already found whatever we need. So we have 2 times. So in place of secant squared x, we can write as y1, and in place of tangent of x, so that's y. So this is what we were asked to prove. So y2 is equals to 2 times y1 times y.